Have you ever wondered what the future of your job looks like? Well, the future is already here, and it's being built inside Amazon's warehouses. This isn't just another tech story. This is the real reason millions of jobs, maybe even yours, are on the verge of disappearing. We've gotten our hands on leaked internal documents from Amazon, and what they reveal is staggering. The company is building a full-blown robotic army with one single, clear objective: to replace human workers on a massive scale. The plan is codenamed Project Nautilus, and the documents lay it all out. By 2033, Amazon aims to replace over 600,000 jobs. That's more than 500,000 people. And this isn't some far-off futuristic dream. It's happening right now. They are deploying a sophisticated fleet of AI-powered machines as we speak, designed to do your job faster, cheaper, and without ever needing a break. Let me introduce you to the soldiers in this new army. First, there's Proteus. Think of it as a super-smart, autonomous warehouse Roomba, but instead of cleaning floors, it moves massive shelves filled with products all on its own. It navigates the warehouse floor with incredible precision, completely independent of human guidance. Then there's Sequoia, a revolutionary storage and retrieval system. It can identify and store inventory a staggering 75% faster than any human team could. Imagine the efficiency leap. But the real game changer, the one that should make everyone pay attention, is a new robot named Vulcan. Vulcan isn't just a machine that moves things. It's a robotic arm with an advanced, human-like sense of touch. It can pick, grasp, and sort individual items with the same dexterity as a person. This is the holy grail of warehouse automation, the ability to handle the delicate, varied, and unpredictable tasks that have, until now, required a human touch. So, why is Amazon doing this? What's the master plan? The documents spell it out in black and white. For every single package that gets processed by a robot instead of a person, Amazon saves 30 cents. Now, 30 cents might not sound like a lot, but let's do the math. Amazon ships billions of packages every year. When you add it all up, that 30 cents per package translates into a mind-blowing $12.6 billion in annual savings. That's the kind of money that reshapes industries. But here's the thing. This story is so much bigger than just Amazon. What's happening on their factory floors is a preview of what's coming for the entire global economy. This is the exact future that figures like Elon Musk have been warning us about for years. He's been very clear in his predictions. AI will eventually be capable of doing every single job, not just manual labor, but creative work, analytical work, everything. Musk, however, paints this as a positive development. He envisions a future where work becomes optional, a world where society provides a universal high income for everyone, freeing us from the need to work for survival and allowing us to pursue our passions. It sounds like a utopia, right? No more Monday mornings, no more stressful deadlines. But there's a huge, unanswered question at the heart of this vision. How do we get there? How do we transition from a world where millions of people have just lost their jobs to this idyllic future of universal high income? Who pays for it? How is it distributed? What does a society where no one has to work actually look like? Nobody, not even the brilliant minds predicting this future, has a concrete, practical answer to these questions. The path from a pink slip to a universal paycheck is completely uncharted territory, and that's what makes this so urgent. This isn't science fiction anymore. It's not a debate for a philosophy class. It's happening right now, in real time, on Amazon's factory floors. The technological shift is here, and it's accelerating faster than our social and economic systems can adapt. We are witnessing the beginning of the greatest labor shift in human history. What do you think? Is this technological leap going to lead us to a better world with a universal high income, or is it a threat to our economic stability? Let me know your thoughts in the comments below. If you found this information eye-opening, please hit that like button and subscribe to the channel for more deep dives into the technology that's shaping our world. Thanks for watching, and we'll see you in the next one. All right, let us talk about what is actually happening in surgical robotics right now. Not the sci-fi stuff, but the real systems being deployed, upgraded, and scaled globally. Because the fusion of AI and robotics in the operating room is not just hype anymore. It is reshaping how surgery is done, who can access it, and what outcomes look like. CMR Surgical, based in Cambridge, United Kingdom, just became one of the first to adopt NVIDIA's IGX Thor platform for their Versius surgical robot. That's a big deal. IGX Thor brings more compute, better energy efficiency, and real-time awareness to surgical robotics. Versius itself is already FDA cleared, the first multi-port, soft-tissue general robotic-assisted surgical device to get through the de novo process. It's compact, biomimics the human arm, and is designed for minimally invasive access to the lungs, thymus, and esophagus. It uses collaborative arms and bedside units to give surgeons direct patient access, with flexible port placement tailored to each case. Now, with IGX Thor, CMR wants to push Versius into a new phase, one where AI delivers live insights during surgery and learns from every procedure to improve the next. Chris Fryer, their CTO, said it clearly: "The goal of AI is not to replace surgeons, but to empower them." And NVIDIA's not new to this space. In just 2 days, they have announced partnerships with Johnson & Johnson MedTech, Karl Storz's Ascensus, Moon Surgical, Virtual Incision, Neptune Surgical, and Stereotaxis. That is a full-stack push into surgical robotics. Meanwhile, India's making its own moves, and they are bold. At the launch of the 450-bed Namo Hospital in Silvassa, Prime Minister Modi watched a live demo of Misso, India's first indigenously developed AI-powered robotic system for knee replacement surgery. Built by Merrill Life Sciences, Misso is designed to enhance precision, reduce recovery time, and improve outcomes. It is a signal that India's not just adopting, it is innovating. Merrill also launched the Misso Endo 4000, a soft-tissue surgical robot that supports general surgery, gynecology, urology, thoracic procedures, all backed by AI-driven 3D anatomical mapping and 5G-enabled telesurgery. That means remote operations are now viable. SSI Innovations is building affordable laparoscopic robots, and Taurian Surgical's AI-based 3D surgical microscope just attracted pre-seed funding from both Indian and international investors. The pipeline is real, and it is growing. India's market for AI-based surgical robots hit $176 million in 2023 and is projected to reach $901.1 million by 2030. That is a 26.3% increase. Globally, the market's expected to hit $25.2 billion by 2030. So yeah, India is not just building for itself, it is building for export. And the tech is evolving fast. Robotic systems now translate a surgeon's movements into micro-actions with sub-millimeter accuracy. High-definition 3D visualization magnifies anatomical structures up to 10 times, allowing for delicate procedures in hard-to-reach areas. In neurosurgery, robotics help navigate critical brain structures with millimeter precision. In orthopedics, they guide joint replacements with perfect alignment. In cardiac surgery, they allow for minimally invasive access to the heart, reducing trauma and speeding up recovery. Patients benefit too. Smaller incisions, less scarring, faster recovery, reduced blood loss, and shorter hospital stays. Some go home within 24 hours. Surgeons get ergonomic control consoles that reduce fatigue and improve focus. And because robotics minimize human variability, outcomes become more consistent and repeatable. Now, layer in AI. Machine learning algorithms are being trained to assist with decision-making, pattern recognition, and predictive analytics. AI can analyze pre-op imaging to plan the best surgical path, then offer real-time feedback during the procedure. That's not just precision, that's personalization. We are already seeing AI autonomy in action. Researchers trained a robotic system using the Surgical Robot Transformer Hierarchy Model, SRTH, to perform parts of a gallbladder removal. It learned from real surgical videos, identified arteries, clipped them, made incisions, and eventually operated without human commands. Full autonomy is not here yet, but hybrid collaboration, that's already happening. India is also pushing into endovascular surgery. At KLS Dr. Prabhakar Kori Hospital, doctors used the Penumbra device, an AI-powered system, to perform a pulmonary mechanical thrombectomy via a transfemoral approach. That is selective clot removal with life-saving precision. But with all this progress, regulation has to keep up. In the EU, AI surgical robots fall under both the Medical Device Regulation and the upcoming AI Act. That means they'll need to meet strict standards for safety, transparency, and human oversight. India's ICMR released ethical guidelines in 2023, emphasizing transparency and patient consent, but they haven't yet addressed robotic surgery directly. That is a gap, especially with the Digital Personal Data Protection Act coming online, which will redefine how health data is handled. Challenges remain. AI's black box problem makes it hard to explain decisions mid-surgery. Data privacy is critical. These systems process massive amounts of sensitive info. Bias is a risk if training data is not diverse. And surgeons need training, not just in how to use the tech, but how to collaborate with it. Hospitals will need better infrastructure, faster networks, and interoperable systems to support all this. Globally, we need regulatory harmonization. Inconsistent standards slow down innovation and complicate safety assurance. A shared framework for AI validation, data governance, and clinical safety would help accelerate responsible adoption across borders. Bottom line, robotic-assisted surgery is no longer a niche upgrade. It's a foundational shift. From Versius in the UK to Misso and Misso in India, from Da Vinci's legacy to NVIDIA's IGX Thor, the operating room is becoming a data-driven, precision-guided environment. If we get the ethics, training, and regulation right, this tech could democratize advanced surgery, bringing it from elite hospitals to rural clinics and from theory to practice. This is the future of surgery, and it's already in motion. All right. Let's break down what GM just unveiled, because this isn't your typical car tech update. It's a full-stack transformation of what a vehicle is, what it does, and how it fits into your life. And if you're tracking the intersection of AI, autonomy, and consumer hardware, this is one of those moments that signals a real shift. So here's the core of it. GM launching conversational AI in 2026 and true eyes-off driving by 2028. That is not just a roadmap. It's a commitment to turning the car into a responsive, intelligent system that adapts to you. And they're not just layering this on top of existing tech. They're rebuilding the architecture from the ground up. Let's start with the AI. Next year, GM vehicles will start integrating Google's Gemini. Yes, the same multimodal model that's been making waves in natural language and contextual reasoning. This isn't just about voice commands. You'll be able to talk to your car like you would a smart assistant, but with real context. Want to find a charging stop near your favorite cafe? Done. Need help prepping for a meeting while you drive? It's got you. Dave Richardson, GM's SVP of Software Engineering and formerly a director at Apple, says the goal is seamless integration. Practical AI that actually makes your life easier. But Gemini is just the beginning. GM's already working on its own custom-built AI, fine-tuned to each vehicle and connected through OnStar. This assistant will learn your habits, anticipate your needs, and even handle logistics like service appointments or route optimization. Richardson gave a pretty wild example. The car could queue up videos for your kids and an audiobook for you before a road trip, detect a wobble in the wheel, and answer questions about nearby landmarks, all without you lifting a finger. Now let's talk autonomy. GM's eyes-off system is set to debut in the 2028 Cadillac Escalade IQ EV. And yeah, it's legit. We're talking full disengagement. Hands off the wheel, eyes off the road. You'll know it, S-active, when the turquoise lights on the dashboard and mirrors light up. That's your cue to relax, check email, or binge something on the Escalade's 55-inch screen while cruising at 63 MEP. Technically, this system is built on sensor fusion, LiDAR, radar, and cameras, working together to create a comprehensive understanding of the environment. It's not just perception, it's decision-making, trained on 700 million miles of Super Cruise data and 5 million miles from Cruise AS' now-retired robotaxi fleet. That data feeds into a unified vehicle architecture that brings propulsion, steering, braking, infotainment, and safety onto a single computer core. The result? 35x more AI performance and 1,000x more bandwidth than GM's previous systems, with full over-the-air upgrade capabilities. And this isn't just a highway feature. Sterling Anderson, GM AS Chief Product Officer, formerly of Tesla, says the system will expand to urban environments and eventually handle errands. That's inching toward Level 3 autonomy, where the car handles most tasks and the driver only steps in when needed. GM's working with NVIDIA to power these systems, and they're promising a rollout that's faster than the original Super Cruise expansion. What's interesting is GM's positioning. While Tesla's pushing robotaxis and fleet services, GM's doubling down on personal autonomy. Mary Barra, GM's CEO, says the focus is on making autonomy a cornerstone of the personal vehicle experience. It's not about ride-hailing, it's about giving everyday drivers the gift of time. And they're not stopping there. GM's also investing in cobots, collaborative robots that assist in vehicle assembly, and expanding their GM Energy business, which includes bidirectional EV charging and home battery systems. Starting in 2026, these will be available via leasing, making it easier for EV owners to integrate backup power and solar into their homes. So yeah, this isn't just a tech demo. It's GM staking a claim in the future of mobility, where AI isn't just a feature, it's the foundation. Between Gemini, Cruise, NVIDIA, and their new compute architecture, they're building vehicles that don't just move you, they understand you, adapt to you, and evolve with you. This is the moment GM stopped building cars and started building intelligent systems.